Hey everyone, Geophysicist Stefan Burns here. Today we are going to examine the continent of Antarctica because this is a place that most people never think about. Very few people have visited. We know very little about Antarctica in comparison to the other main continents on our planet, yet it has a huge impact on Earth's geology, geophysics, and climate. And well, there are some factors here that we have just recently learned about in the past few decades that could change everything if activated. And I'm specifically talking about the volcanoes that have been discovered under the ice sheets of Antarctica. We have more than 100 volcanoes scattered throughout this part of Antarctica, fairly close to the magnetic field, though the magnetic field has been moving further away from that location. But these are mostly subglacial, though as you can see, some of them do have expression at the surface. For example, these volcanoes right there. They're so large that they're actually standing above the ice sheets that have settled down to the sides of them. And if this rift valley, because this is indicating that there's actually a rift valley here, very similar to Africa, if this rift valley was to get activated in a significant way, which it is not at this moment in time, we could see some dramatic changes unfold at Antarctica because you could get mass lubrication of these ice sheets to then discharge. Of course, any magma that's erupting from the surface would melt any ice at the surface as well. This released a lot of water, not only into the oceans, but into the atmosphere, and this could completely destabilize the climate system. You also have to consider the albedo effect. Antarctica here, every summer for the southern hemisphere, basically every December, January, that time frame, Antarctica is permanently pointing towards the sun, getting 24-hour sunlight, reflecting a lot of energy back. So if Antarctica here did not have this ice and this snow and this high albedo, we would be receiving a lot more energy here on Earth, and that would quickly accelerate the greenhouse gas effect because our atmosphere in general does like to hold on to heat. And with more water vapor and other greenhouse gases, that accelerates. And so this is a very active dynamic at play right now with our Earth, though thankfully these volcanoes are fairly inactive. We do have evidence of there being a big volcanic eruption back in 325 BC with 23,000 square kilometers of ash having been deposited underneath the ice. These are shield volcanoes, very similar to Hawaii. So that's the type of effusive eruption like this. And when they get activated, you can form these large igneous provinces, these flood basalts. We see that across the globe in a variety of locations where it just keeps pumping out magma. And if that was to happen, then things could get really serious. Now, before we go into some of the data, I just want to show you quickly a couple interesting things. We see that the magnetic field here is located fairly close to all this volcanism throughout this part of Antarctica, the Rift Valley. And if you go to the northern hemisphere, we will also see something very interesting, and that is something I've talked about before. This is the fact that we have a supervolcano located in the position where the magnetic pole in the northern hemisphere often is, and we have it accelerating right now towards Gokul Ridge, which has a lot of volcanic activity to it, which is anomalous because it's a very slow spreading center, yet we have evidence of a massive supervolcano eruption there 1.1 million years ago, 3,000 cubic kilometers of material ejected just in 1999. There was a seismic swarm that produced 3 new volcanoes, pyroclastic flow deposits underneath the water. So it seems that at the poles of our planet, volcanism is common, right? We have that, and it's an active part of the larger geophysical system. And here we have a geologic map showing the location of all these volcanoes in Antarctica. There is a confidence factor to this data because a lot of them are buried under the ice, and so we get the reflections or the GPR data to see what they look like, but we can't be 100% sure. Though the surface expression volcanoes, of course, are telling us that there's a lot of volcanism here, that there's an entire rift valley here. We see our topographic elevation data there. So we're here seeing the Trans-Antarctic Mountains. This is the Ross Ice Shelf. the Ross Sea. This is where the magnetic pole in the southern hemisphere is located off to this direction. Here's Marie Birdland. This is where all these volcanoes are. And we see the Ronnie Flincher ice shelf here. And so we see that they spread out throughout this entire zone. Some of them at a very high confidence, others less so. But in general, there are 100+ volcanoes here, mostly of a basaltic type. So they're shield volcanoes. So they have very low slope, but they have a huge amount of volume to them. And the taller a shield volcano is, then you know it's a quite old volcano because it had time to build up its slope and overall build up its height as a result. Hawaii is a classic example of a shield volcano. It's actually one of the largest mountains. It is the largest mountain in the world if you categorize it from its base at the bottom of the ocean going all the way up. But it's had to build up a tremendous base because that sort of lava just diffuses out and really flows readily. And that's the key as it relates to Antarctica. If these volcanoes were to wake up in a significant way due to some new pressure dynamics or new push of convection and magma from the mantle to this location of the planet, we could see large-scale destabilizations of these ice sheets in a pretty rapid time scale. I mean, this could be like years to decades depending on the strength of these eruptions. It's not out of the question. We're not seeing evidence of that now, but with the magnetic poles moving so much right now, perhaps that's something that is at play. And here we have an example of some geophysical data from Antarctica showing these volcanoes buried underneath the ice. Check out our scale bar here. This is 10 kilometers per tick, where it's only about 500 meters per tick there. So keep in mind that this is horizontally very exaggerated. But we see these cones like this, those are volcanoes. So they look quite steep here, but again, this is nearly about 5, 6, 7 kilometers across for this volcano. So it's actually a very broad, wide shield volcano. And we see them very clearly with this topographic data. So it's not just one or two volcanoes. Like if we go to Hawaii, for example, we see quite a few volcanoes, but you have in general the Big Island and you have Maui and that's it. And it's a pretty small area overall for that hotspot and that mantle plume coming up. For Antarctica, it's really spread out over a wide region, just like the surface expression of the African superplume and the East African Rift Valley. It's much more like that system than it is, for example, Hawaii. And we're seeing now changes actually to the African superplume, the historic eruption of Haile Gubi volcano in Ethiopia being a good example of that. If we had something similar at a widespread scale happen in Antarctica over a short period of time, things could radically change on our planet in the blink of an eye. And we know the volcanoes in Antarctica are basaltic in nature and are shield type volcanoes because of their height compared to their volume. So you have stratovolcanoes here which grow much taller and they have more sticky magma. It is felsic, so think like granites and think like plagioclase minerals, quartz crystals, things of that nature. Whereas with mafic magma, it doesn't have that stickiness to it. And it's much more effusive. It spreads out. And we see that, yeah, maybe there's a couple compound stratovolcano, shield volcanoes here, but in general, they fall right along this known distribution of volume to height for shield volcanoes. And so that data is clear. And just again, check out how many dash marks there are. So there's a huge number of volcanoes in Antarctica. And here we have a comparison between the East African Rift axis and the volcanoes there and Antarctica. So we have this rift system. We see all these volcanoes, either surface expression or subglacial. And this is not showing all of them. For Marie Birdland and the adjacent areas, we also see a string of them up there near the Ross Sea. And that's closer to that magnetic pole in the southern hemisphere. And you just in general see the parallels here. So there's a lot of similarity. So the fact that we have all this volcanism, we just recently discovered this. So we're still learning what this is and the systems at play and everything. But this is clearly showing that there is a mantle plume coming up, some sort of convection dynamic underneath Antarctica. We have very similar dynamics also with the Arctic Circle in the northern hemisphere, again with Gokul supervolcano, because we have the Gokul Ridge there, the spreading center there. So we have two spreading rift axes. And there seems to be a lot of volcanism for both the Arctic Circle and the Antarctic Circle as a result. And we also have the magnetic poles also located right in that area. And that's where the energy from our interplanetary interstellar environment flows in. Any charged particles flow down those magnetic cusps. So it seems to me that everything is connected and that over longer time scales, that energetic flux from our space environment really has a profound effect on the geophysics at play here on Earth, which can affect a lot of different factors. For example, climate, and then if there's a big volcanic eruption, even our weather. For example, you can have the year without a summer. We've had that happen just in the recent geologic time frame of the past couple hundred years, and it could happen again. So to summarize, there is a tremendous amount of volcanoes underneath the ice sheets in Antarctica. It's literally tearing the continent apart, and these are just an expression of that larger geologic rifting that is occurring there. We still know very little about this because we just recently discovered all these volcanoes in the past 10, 20 years, and we have, in general, a lot more research to do, but we do see, based off of some samples of the rock types there, that this is very similar to the East African Great Rift Valley, and we're seeing increased activity there right now. So perhaps we're going to be seeing increased activity underneath the ice sheets of Antarctica in the near future. It's certainly possible if this is a sign of larger geologic processes unfolding within the mantle. That is certainly possible. We live on the surface, the crust, we see and observe what happens up here. But the Earth is a very big planet, and there's a lot happening on the surface that we have no clue about. And if there are larger changes unfolding, let's say with new convection dynamics, that's depressurizing certain parts of the mantle and causing them to upwell and this magma to come up, well, we could see things change very, very quickly. We have evidence of powerful subglacial eruptions in Antarctica, major eruption in 325 BC. As I said earlier, this is 23,000 square kilometer ash layer, volcanic explosive index of about 3 to 4. It's hard to estimate this exactly. So there's a lot happening right now on the planet, and as of right now, Antarctica seems to be fairly calm, but it's a very important part of our Earth geophysical system, specifically also with our climate system because of the albedo. And if this does change, everything else is probably going to have to change in response. So I will keep you up to date on everything that is happening with the Earth geologically, geophysically, with our sun, with solar activity and space weather, with our planets, planetary alignments and resonances, and also with interstellar and cosmic forces. I release videos almost daily. Thank you all so much for watching. I've been your host, Stefan Burns. Please subscribe, smash that thumbs up button to help the channel grow. Hope to see you around. Wishing each and every single one of you well. Please take care of yourselves. I'll see you all in the next video.